Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to part one of our three-part deep dive into KubeCon Atlanta 2025. Over the next 3 episodes, we're covering everything that happened from November 12th through 21st, the CNCF's 10-year anniversary, the announcements that will reshape platform engineering, and the honest conversations about what it takes to keep this ecosystem sustainable.
Today, in part one, we focus on the technical breakthroughs that prove Kubernetes isn't just supporting AI workloads, it's being rebuilt as an AI-native platform. Tomorrow, in part two, we'll cover platform engineering reaching consensus and real-world adoption stories. And in part three, we tackle the harder questions: maintainer burnout, community sustainability, and what the next 10 years might look like.
But first, let's start with a mystery. Google's on stage at the opening keynote, and they do something unusual.
November 2025, Kubernetes turns 10. Google's on stage at KubeCon Atlanta, and they donate a driver to CNCF Live. Not a project, not a tool, a driver for GPUs.
Wait, why would Google donate GPU infrastructure code in the middle of a keynote? That seems specific.
Because it's not about the driver, it's about what the driver represents. Kubernetes isn't adapting to AI workloads anymore. It's being rebuilt for them.
Okay, that's a strong claim. Back it up. What changed at KubeCon 2025 that makes this different from, say, KubeCon 2023?
4 technical announcements. Let me walk through them and you'll see the pattern.
I'm listening.
First, Dynamic Resource Allocation, DRA, reached GA in Kubernetes 1.34. This is the driver Google donated on stage.
GA means production ready, not experimental, not beta. Why does DRA matter?
Because of how Kubernetes used to allocate GPUs. The old device plug-in architecture, been around since Kubernetes 1.8, would grab any available GPU and assign it to a pod. Sounds fine, right?
Except modern servers are NUMA, non-uniform memory access. GPU on NUMA node 0, CPUs on NUMA node 1, and suddenly your expensive training job is crawling because of cross-node memory traffic.
Exactly. And the performance hit? 10 to 40% degradation.
Wait, hold on. 40%? That's not optimization territory. That's a misconfiguration disaster.
Tim Wickberg from SCB Made, the company that makes Slurm, the dominant HPC scheduler, he said HPC workloads can see 30 to 40% performance differences from misaligned versus aligned resources.
Okay, let's do the math. $5,000 a day for a pre-training workload, 40% waste. That's $2,000 per day per node just evaporating.
Scale that to 100 nodes. $200,000 a day.
From something you can't even see unless you're profiling at the NUMA level. That's terrifying.
DRA solves this. It understands topology at the hardware level. It knows which CPUs, memory, and GPUs share the same NUMA node. It can make intelligent placement decisions to keep compute and accelerators on the same node, preventing those cross-NUMA node traffic bottlenecks.
And this is GA now, production ready, not coming soon, not experimental. If you're running GPU workloads on Kubernetes without DRA, you could be losing nearly half your performance.
On misaligned workloads, yes. The scary part is you wouldn't even know unless you're profiling at the NUMA level.
So what's the migration path? Can teams actually adopt this?
Here's the good news. Kubernetes 1.34 includes both DRA and the legacy device plugins. No forced migration. You test in development first, measure the performance difference. If you're seeing greater than 10% improvement, you plan your production migration.
And the DRA net driver Google donated?
It implements the standard DRA interface. Google's basically saying, here's the reference implementation. Topology awareness is now baseline infrastructure for AI.
If you're running GPU workloads without DRA, you're burning money.
Exactly. But here's where it gets interesting. DRA isn't just for GPUs anymore.
Wait, what else is there?
CPUs. The CPU DRA driver was announced at KubeCon 2025.
Hold up. Why do CPUs need topology awareness? Aren't they already on the CPU?
Think about HPC workloads, computational fluid dynamics, molecular modeling, financial simulations. These aren't GPU workloads. They're CPU intensive, but they need precise CPU placement and memory locality.
And HPC has resisted Kubernetes for years.
Right. Slurm dominates 60% plus of the top 500 supercomputers. Why? Because Kubernetes couldn't handle CPU topology requirements. But now, with CPU DRA,
Kubernetes and Slurm can work together.
Tim Wickberg said, quote, we've seen 30 to 40% performance differences in HPC workloads from resource alignment. DRA brings that awareness to Kubernetes. This opens the door for HPC workloads that were previously impossible.
So Kubernetes is converging with HPC. That's a bigger deal than it sounds.
Right, because HPC has decades of battle-tested knowledge about resource scheduling. If Slurm and Kubernetes can work together, you get the best of both worlds. Same infrastructure can run containerized microservices and high-performance computing.
But it also means Kubernetes is getting more sophisticated. This isn't your 2015 container orchestrator anymore.
That's the tension. For web applications, this is overkill. But if you're running CPU-intensive scientific computing, this is transformative.
Right tool for the job.
Exactly, which brings us to announcement 2, the Workload API, coming in alpha for Kubernetes 1.35.
Workload API. I'm guessing this solves the gang scheduling problem?
You've been reading ahead. Yeah, here's the scenario. You submit a 1,000-pod distributed training job. Kubernetes, treating each pod independently, successfully schedules 800 pods.
And the remaining 200 never get resources. Meanwhile, those 800 running pods are consuming thousands of dollars an hour in GPU time, doing nothing, waiting for workers that will never arrive.
Exactly, the partial failure nightmare. Eric Toon from Google said, pre-training workloads use every accelerator the customer can acquire. Hardware failures happen every couple of days. The time to recover and restart is a significant reduction in cost.
So Workload API makes Kubernetes understand that certain groups of pods must be scheduled atomically, all or nothing.
Right. If the cluster can't accommodate the entire workload, none of it starts. You don't waste resources on partial failures.
This is the gang scheduling problem that HPC solved decades ago. But Kubernetes was built for stateless microservices, each pod independent. AI forced the re-architecture.
That's exactly it. Kubernetes at 10 years isn't slowing down. It's being redesigned at the infrastructure and scheduling layers to be AI native.
Okay, announcements 1 and 2 are about infrastructure redesign. What's announcement 3?
OpenAI. 10 petabytes of logs per day. They're using FluentBit as the log collector across their Kubernetes fleet, and they noticed FluentBit consuming way too much CPU.
Define way too much.
They profiled with perf, the Linux profiling tool. fstat64, a system call, was consuming 35% of CPU time.
35% on a single system call? What was causing it?
iNotify, watching log files for changes, unnecessary in their architecture. So they disabled iNotify in the FluentBit config. One line of code. Result? 50% CPU reduction.
Wait, 50% reduction from disabling file watching?
Yep. And here's the kicker. 30,000 CPU cores freed.
30,000 cores? Let me get the calculator out. Cloud pricing, roughly 10 cents per core hour, 30,000 cores times zero point 0.1 times 24 hours times 30 days. That's $2.16 million per month.
From one line of code.
Okay, but how many platform teams actually profile their critical services? Be honest.
That's the point. OpenAI isn't special. They're just measuring. Fabian Ponche from their Applied Observability team said, quote, "Sometimes you might just find something surprising."
The fruit is low-hanging. You just have to look. What's announcement 4?
Kubernetes Rollback. After 10 years, it finally works.
Hold on. Kubernetes launched in 2015. For 10 years, cluster upgrades were one-way operations?
If an upgrade broke something, you couldn't roll back. You could only try to upgrade forward to a fixed version. This kept organizations on old versions accumulating security debt.
And now?
99.99% upgrade success rate across GKE control planes and nodes. Skip version upgrades supported. You can upgrade once a year instead of quarterly.
That's a 75% reduction in operational burden just from safe upgrades.
Gigi Macload from Google announced this, but there was also a memorial. Han Kang, who passed away in 2025, worked extensively on Kubernetes reliability. Macload said, quote, "This has taken literally a decade of effort. Han Kang's passing really hurts. This is a lasting legacy."
That hits different. We talk about technical achievements, but there are people behind all of this.
Yeah, Kubernetes at 10 years is bittersweet. Amazing technical progress, but also the reminder of what it cost to get here.
Let's connect these 4 announcements. DRA for GPU and CPU topology, Workload API for multi-pod coordination, OpenAI's profiling lesson, Rollback after 10 years. What's the through line?
Infrastructure redesign, scheduler redesign, operational maturity, production reliability. Kubernetes isn't just supporting AI workloads. It's being rebuilt at every layer to be an AI-native platform.
So when people say Kubernetes is getting too complex, what's the right response?
Loaded question. Yes, DRA adds complexity, but the alternative is 40% of your GPU spend down the drain. That's not complexity tax. That's appropriate sophistication for modern workloads.
I buy that for organizations running AI workloads at scale. But what about the majority of companies not doing large-scale distributed training?
Fair. If you're running single GPU workloads, DRA overhead probably isn't worth it. If you don't have multi-pod coordination needs, Workload API is overkill. Get the basics right first.
Basics like profiling.
Exactly. The OpenAI lesson applies to everyone. How many platform teams have continuous profiling in production? How many regularly use perf or eBPF-based tooling?
Very few.
And that's free optimization.
If OpenAI found 2.16 million a month in savings, you likely have opportunities. Maybe not 30,000 cores, but 300, 3,000. Still transformative.
All right, let's get practical. If I'm a platform engineer listening to this, what do I do Monday morning?
This month, December 2025, 3 actions. 1. Test Kubernetes 134 in a development cluster with DRA enabled. 2. Profile your #1 CPU consumer. Use perf top or eBPF-based tooling. Spend 30 minutes. 3. Check if you're losing performance to NUMA misalignment right now.
And then what? Assuming you find something.
Q1 2026, measure DRA performance improvement. If you see greater than 10%, plan production migration for Q2. Pilot Workload API for multi-pod training jobs. It's alpha in Kubernetes 135. By Q3, Workload API should hit beta. Plan production adoption.
What about the skip version upgrades?
Test upgrading annually versus quarterly. If you can reduce upgrade frequency by 75% while maintaining security currency, that's a massive operational win.
When should you not adopt these technologies?
Single GPU workloads, DRA overhead not worth it. No multi-pod coordination needs, Workload API unnecessary. And critically, if you don't have operational maturity for complex orchestration, get the basics right first. Profiling, monitoring, incident response.
That's the sobering part. Kubernetes at 10 years has incredible capabilities, but it assumes a level of operational maturity that most teams don't have.
Right, and that's where the OpenAI lesson becomes universal. Profiling isn't advanced. Perf is a standard Linux tool. 30 minutes on a Monday morning. If you find a function consuming more than 20% of CPU time, investigate.
One optimization could fund an entire platform team's salary.
Exactly. The technical announcements are impressive. DRA for GPUs and CPUs, Workload API. These aren't incremental improvements, they're architectural shifts.
But the 30,000 cores story is the reminder that basics matter. Profile, measure, optimize.
AI native platform requires both sophisticated infrastructure and operational discipline.
Kubernetes at 10 years isn't slowing down. If anything, it's accelerating. DRA going GA, Workload API arriving. These aren't incremental improvements, they're architectural shifts.
And for the folks wondering if Kubernetes is too complex now,
Ask a different question. Is the complexity justified by the problems it solves? If you're running large-scale AI workloads, losing 40% to NUMA misalignment, then yeah, DRA complexity is worth it. If you're not, maybe Kubernetes isn't the right tool.
that's the honest answer. Kubernetes has evolved to handle workloads that didn't exist in 2015. AI training across thousands of GPUs, geotemporal ML at Pokemon Go scale, 10 petabytes of daily logs at OpenAI.
But if your workload is a standard web app with a database, you probably don't need the AI native features. And that's okay. Use the right tool for the job.
Final thought. What's the one thing listeners should remember from this episode?
Measure before you optimize. OpenAI found $2.16 million a month because they profiled. If you're not profiling your critical path services, you're leaving money on the table.
And if you are running AI workloads, DRA is production ready. Test it. The 10 to 40% performance difference is real.
That's the technical story from KubeCon 2025. Dynamic resource allocation going GA, CPU DRA enabling HPC Convergence, Workload API solving gang scheduling, and OpenAI's reminder that profiling matters.
But there's another story from KubeCon that's just as important. After years of definitional chaos, what even is platform engineering? The industry reached consensus. 3 principles, real-world case studies from Intuit, Bloomberg, and ByteDance, and the anti-patterns that doom platform teams to failure.
Tomorrow, in Part 2, we cover platform engineering's coming-of-age moment, the puppy for Christmas problem, and why self-assessment might be the most important tool you're not using.
This has been Part 1 of our 3-part KubeCon Atlanta 2025 coverage.
Test DRA in development, profile your top CPU consumer, check for NUMA misalignment. See you tomorrow.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.